In this video, I'd like to talk about congruent triangles and the angle side angle congruence rule or postulate. And essentially what this is saying is that if we have two triangles and they share two sets of equal angles and the side between the equal angles are equal as well in both triangles, then the two triangles are congruent. They have the same size and the same shape. And in other words, if we look at specific examples, we can say that angle A and angle D are equal. The side AB is equal to DE, and angle B is equal to angle E. If we know just this about the two triangles, then we know for sure that triangle ABC is congruent to triangle DEF. And with this congruence rule or postulate, we can either take it as a postulate or it's possible to prove this from basic principles. And this is something that you can actually understand intuitively. So let's take a closer look at that. Let's imagine that we have two different triangles. And let me draw one here very quickly. And we have another triangle, which I'll draw in a moment. But in this first triangle, we know that it has this angle here, this side length, and this other angle. And these two sets of angles are going to correspond with two sets of equal angles in the other triangle. And the side length between the equal angles will also be equal to the side length between the equal angles in the other triangle. So let's imagine what that triangle will have to be. And to do that, let's start by just drawing this segment here, this equal side here. And I'll do it in yellow. And this is not going to be drawn perfectly since we're doing this by hand, but we can at least reason through this and understand why angle side angle is a valid congruence relationship. So this side length here is the same as this one here. And for this other triangle, we only know these two angles. So we have this orange angle here, which is about that size, and we have this green angle here, which is about that size. And we don't have any knowledge of what the other side lengths in the triangle have to be. So we can imagine that they can be any length we want. The only restriction is that it has to be at this angle. So if we start drawing this line segment, it can be as long or short as we want. So maybe we'll make it really long for now. And likewise, this line segment here could be any size, but it has to be at this angle here. And so we can imagine drawing this as long as we want. And what you'll see is that these two line segments meet at some point here. And there's only one way to actually draw this triangle, and that's where these two line segments meet. And when they do meet at this point, that constrains how long they are. And in fact, you can roughly see visually that they look equal to their corresponding side lengths in the other triangle. Now again, this is not drawn perfectly, but what you can see is that this length here and this length here, these would have to be equal. We're allowed to draw this length as long as we want, but there's only one length so that it would actually intersect this bottom line. And likewise, for this bottom line, we can draw it as long as we want, but there is only one length where it would actually close off the triangle. And so this side length here would have to be equal to this side length here. Now, like I mentioned, it is possible to prove this from basic principles. And in Euclid's Elements, that's exactly what's done. This is proven from just basic common ideas that we can all accept. But in modern geometry, it's often taken as a postulate, something that we just assume to be true, since, like I mentioned, even though we can draw these side lengths as long as we want, there's really only one way to draw them so that this actually forms a triangle. And so therefore, when you know two sets of equal angles and you know the side length between those two sets of equal angles is equal as well, then you know for sure that these two triangles are congruent. And that's by the angle side angle relationship. So let's look at an example problem where we have these two triangles and we need to show that they're congruent to each other. Now, in the left triangle, you can see it has an angle, some side length, and another angle. And in this second triangle, you can see it does share the 63-degree angle. It shares the side length next to it, but we don't know anything about this angle yet, since this is a triangle, which means that the angles add up to 180 degrees. So you can solve for this missing angle. We can call it x. We can say that that missing angle plus 45 degrees plus 63 degrees, these have to add up to 180. And from that, you can determine that this has to be a 72-degree angle. And then therefore, you know that you have this angle side angle congruence relationship. You have two sets of equal angles, and the side length between those sets of equal angles is equal as well. So therefore, the two triangles would be congruent triangles.